So hi, BrazilJS. Whoa, it's really loud up here. Welcome. This is me, Stván, which is a short version of Flaki. That's my Fox, my co-presenter up there, Bela. You can see them sneak up on the stage. They were sneaking out some Google info in the previous blog. We are gonna be talking about how I shrunk the scripts, which is basically the secret life of JavaScript on microcontrollers and other hardware. Who have tried any hardware here? Like Arduino, Raspberry Pi, anything like that? Okay, they're like exercising. Good. All right. So we're gonna talk about exactly that kind of stuff. I'm a JavaScript developer. I work with Mozilla, their browser company, and browser nonprofit. I work with their Devrel team, which is a short for people talking to developers, so like all 2,000 of you. I'm part of Mozilla Tech Speakers, which is a program that Mozilla has for putting people like me and like you on stage to talk about open web technologies. And I'm working on a bunch of JavaScript stuff. We're going to talk about that on hardwares, so microcontrollers mostly. Who knows who this guy is? All right, shout it. Shout. Right, exactly. 2009 JSConf EU Node 0.2 is announced. Yeah, it was a beautiful day for the JavaScript ecosystem. A few years ago, I happened to write a blog post. I was like, I've been doing a lot of stuff, a lot of talks on JavaScript. It just started. I've been researching a lot of the language. ES6 was just happening. That was just a thing. So I wrote an article called The JavaScript World Domination, because the more I was researching, the more I saw JavaScript taking over the world. There's a reason Ryan Dahl is on that slide, because I think Node was essential to get JavaScript into all kinds of devices that previously didn't have that. Let's not talk about LiveScript and the server version that Netscape had and all of those things. If you're curious about stuff, I'm going to share the link to the slides. At the end of the slides, there's a reading list with all the links you might want to follow up on after the presentation. So yeah, basically, JavaScript world domination started 20-ish years ago, but Node rejuvenated that push by bringing JavaScript out of the browser and into the hands of people working on servers, people working on their command line. Every single talk has mentioned in some way Node.js idle by mentioning Babel or transpiling or various server-side functions and who knows what you might be coding in a editor that is powered by Node using Electron and a bunch of other stuff. So it was also the start of something beautiful, JavaScript and hardware. And by hardware, it's arguably NodeBots, the community of NodeBots that actually started putting JavaScript into good use to work on microcontrollers and different hardware devices. That was previously not possible because previously JavaScript was a thing for the browser. So the NodeBots community started building robots that were powered by JavaScript, and I'll talk a bit later about what exactly was it powered with. But they started building not just bots, which is Node robots, but Node boats, and Node copters, and guess what that is? Yeah, even Node rockets. That is pretty cool. So problem with that one was it was Node all the way down. It was done with Node robotics called a tool with Jony 5. Now, if you know, there's just been a conference in Carlsbad in the West Coast in the US, JSConf US, returned this year, and they just announced that the Jony 5 library just went 1.0. So congratulations to Rick and the whole team who managed to pull it off. Who have heard of Jony 5 here? All right, a bunch of folks. So Jony 5, for those of you who haven't played with it, is basically this library that lets you use Node.js to communicate to all kinds of hardware. Initially, it was Arduinos, but now you can use it for pretty much everything. So how these things worked usually, node copters and node rockets and node boats, is that you had Node.js running somewhere on a computer. And this is an important point. Node.js was running on a computer, and it was controlling some devices. So I'm not going to, for the sake of brevity, I'm not going to go very much inside of this. But this is a thing using the Fermata protocol. And there is a very good explanation of the Fermata protocol and Joni 5 in general by my very good friend Noobcat. You might know her, or Sis Hinton. She's amazing, and this was one of the first presentations that got me into hardware, so I can very much recommend it. She talks about how Node.js communicates with Arduino and other devices. So again, for all of these devices, you needed to have a computer that controlled some microcontrollers. So JavaScript wasn't really running on the microcontroller, it was running on a computer. Maybe that computer was a tiny Raspberry Pi, but a Raspberry Pi is still a computer, right? You have Raspbian or some kind of like operating system that powers it. So they put this Raspberry Pi on the nodecopter, and the nodecopter controlled some of the servos and devices itself, but it was running on a computer. We had to go smaller, and to go smaller, we have to go back a bit to 2015. This tweet was taken in 2015, one of my early talks about JavaScript and hardware in general. I was talking about how to run JavaScript on IoT devices, and that's a Tessel in the background. The Tessel is a, well, they started out as a startup in the US. It ended up as an open source project I've been contributing to. Basically, their goal was to put JavaScript onto microcontrollers that were not like a whole computer. It wasn't really microcontroller for one version or another, but you know, it was something in between. It was a small device, a resource-efficient device that could run JavaScript, and they wanted to make it understand Node. There's a whole talk about why that didn't quite work out. John McKay has given a whole post, like a retro session on what worked for Tesla and what not. But this was like years ago, again, like 2005. But it was enough to start me to think about hardware and JavaScript in the first place. And the reason, you might ask, why it's important to run JavaScript on hardware, and the answer is very, very interesting. There's this guy, Jan Jumboom. He will tell you in a long talk or in a short blog post that why it actually makes sense to run like a JavaScript virtual machine on a microcontroller that has limited resources and limited computing power, and it's important how much battery you use because you might be running from a battery. He will go into a long explanation why that was important, but actually people just wanted to run JavaScript on a fucking watch. Why? Again, well, it's if you have been paying attention, JavaScript's ubiquity, and Daniel was referring to JavaScript being a easily accessible language. JavaScript is easy to use and is everywhere. Why not you would want to use JavaScript to program microcontrollers and devices like your smartwatch? We'll get back to this, why this is important. But the whole thing started, I think it was like 8 years ago. It goes back that big. If you go on and look up Espruino, who heard of Espruino? Hands up. Yeah, you need exercise. It's like 5 p.m., you're going to sleep. All right? Not a whole lot of people. So Espruino was one of the first JavaScript engines that could run on a microcontroller. So the important thing about a microcontroller is it's tiny. Let's just say it's resource constrained. It has a few kilobytes of memory if you're lucky. It has maybe a few hundred kilobytes of flash memory. That's how much storage you get. And you will have to fit the whole program into it. The whole firmware, actually, which is these devices don't have operating systems. You create a firmware, which is basically you write a whole program that will control the whole device. No file system, no exceptions, no networking. Everything is controlled using your one program that you write. And you only have a few hundred kilobytes for this. So it's important that your thing runs on this device. And as we all know, a lot of people tried putting a existing writing a JavaScript engine is not easy. We can agree on that, right? So a lot of people tried to put an existing one onto a microcontroller. It didn't work out for various reasons. Espruino is one of the very first ones that were built from the ground up to support these tiny devices. Why it's important, it's also one of the most accessible ones. It had like this web IDE that you could use. You could just hook it up to your computer. You could write some JavaScript code and it would run on the device. You would blink an LED or whatever your heart desired. And why it was very important is because Espruino started out with this little device, the Espruino, and actually this was a second device, but Espruino was a device itself. But later on, the Espruino engine itself found its way to other devices, including the ESP8266. You might have heard of it as Node MCU. It's this device that actually costs like a few dollars. It has Wi-Fi built in, and it emulates Node APIs, and you could put Espruino on it and program it with JavaScript. A few dollars will get you a programmable JavaScript microcontroller with Wi-Fi connection. How cool is that? And that was like 2-3 years ago. This is like the old stuff. So that really kickstarted this whole internet ecosystem. So, okay, you know JavaScript, you get some of these devices, you build your sensors. But the problem is you still have to control those somehow. So that's why you can try. It has Wi-Fi. You can host like a web UI or use like some applications to query your temperature readings or toggle your lamps. But Mozilla actually has a project that is basically a gateway for your IoT devices. You build all your JavaScript devices or buy them off the shelf. You can buy like smart lights and smart bulbs. And instead of controlling them from a closed application on your mobile phone, you could just put a gateway in between them and let Mozilla handle that. You just connect to the Wi-Fi, you connect to the UI, and you toggle your lamps and do whatever interesting things you want to do. So it was like, hey, you can build IoT devices. Why not let you build control systems and like dashboards that let you control your connected life? So this is also interesting. So if you touched on smart light bulbs, is that the last Espruino device or the latest Espruino device actually uses Bluetooth connections. And why Bluetooth is important is because it has a BLE or Bluetooth low energy. If you see marketing people, you will see them refer to it as a Bluetooth smart protocol. It has a bunch of names, but the most important thing about it is it lets these devices communicate using low energy consumption. So you can have a device operated from a battery, that reads temperature sensors without the need of replacing the battery or charging the device for a year, and you could still query the device and read data off of it. So Bluetooth was a very interesting thing, because I've been talking to you about how you could use JavaScript or microcontrollers, how you can use Node on it, but actually this thing is in your browser. So I think we got to the first, let's see if this will work out, first demo of the day. Let's hope for the best. Ta-da. Oh, hello. Or maybe not hello. All right, let's try this again. Come on, I want to view my camera. Okay, let's try this again. Now much better. So let me introduce you to Frankie the cat. Frankie the cat is a Lego box set that you can buy. The interesting thing is that it uses Bluetooth to communicate with the device. So there's a button on the device. I'm going to push it. You're going to see Frankie's face light up. And I'm going to open this browser window, and I'm going to click this. You will see the device show up. I'm just connecting via Bluetooth connection to this device. This is a web page. I'll show you the source code in a bit. And it turned out I was talking too much. All right, let's try this again. And oh, come on. So classic. It's literally worked 5 minutes ago, right? Frankie's lazy. Okay, let's try. Oh no, Wi-Fi is killing us. Hey, gosh. Oh, let's see. Let's see it again. Okay. Weird. Oh, there you go. Let's try this again. You can see Frankie's not amused by the Wi-Fi issues. There you go. So basically what happens, let me show you just the code quick because we're running out of time. This is the whole code, 59 lines. Everything is in HTML. You basically what you do, and that includes a lot of empty lines. Basically, there is this browser API called Web Bluetooth that's currently just a proposal. You can turn it on in Chrome, and Firefox has a special edition of Servo, their new browser engine, that can run Web Bluetooth as an experiment. It basically, hey, I want to select a Bluetooth device. The user gets a list of Bluetooth devices associated, and you can send commands to the device. The interesting thing here is basically I'm sending this data here, which basically sets some configuration in the device. So Frankie will roll their eyes. Okay, that's basically the whole thing. I'm just communicating to the device via Bluetooth. Again, you can just buy this thing online. It will ship with an iOS and Android application that you can use to control it. But with nothing but using a browser, you can already control this device. There's also bindings for BLE, Bluetooth LE for Node.js. So if that's more your thing, you can also do that from there. Let me see if nope. All right. Thanks, Frankie. Yeah, so I have a few slides here about the more depthy details of JavaScript and engines on hardware. I'm going to skip some of these. If you're interested in some zesty details and some freaky, very small JavaScript engines, I've given a similar talk at JSConf Asia this year. So just search for it, and you can watch the portion that we are going to be skipping through here. Mandatory mention of Benedict Moirer. And yeah, we need to go smaller. We're going to go with Samsung open source with just a very small mention. I just mentioned this, that a lot of people tried putting a Microsoft JavaScript engine onto a microcontroller. Samsung open source was one of these. They really wanted this IoT JavaScript thing to work. And they figured out that all the things that on the market were just not usable enough or not good enough. So of course they did what everybody does when they are a hacker. They just reinvented the wheel, or more like reinvented the JavaScript engine and wrote one from scratch. Took them a few years, but JerryScript now powers an alarming amount of devices out there. It's a very small JavaScript engine. It runs with less than 64 kilobytes of memory. How much is your desktop browser consuming? It uses 200 kilobytes of flash memory, and it's fully ES 5.1 compliant. Actually, by now it supports a bunch of ES 6 and 6 plus features. So I think async await, for example, is in there already. So the interesting thing about this is there is a device called the microbit. If you take something away, if you're like, I'm going to do hardware hacking stuff, what do I start with? This is the device I recommend you go with. The microbit is super neat. It's like $15. That's in Brazil. It's only going to cost you like twice as much, I guess, with all the import fees. But it's still, it's still pretty cheap. It has all the stuff built in. It has some LEDs, so you don't have to wire and hook up and solder. It has some sensors, so you can throw it around and read the accelerometer readings. So it has a bunch of stuff already built in that you can use. It has a web IDE. Again, you can just code on the internet in a browser and download the files from there. It supports JavaScript because it runs JavaScript on this device using JerryScript. It actually bundles JavaScript. So there is this conference, and we are getting back to our original point here. This guy goes on stage and announces that, have you ever heard of Pebble? Anybody had the smartwatch Pebble? You know, they just, at some point, again, I talk a bit more about this at my JS Conf Asia talk. They basically switched the watch to actually render the watch clock face from C++ to JavaScript. The original C++ code was 250 lines of code. The JavaScript code was 1/5. And it worked exactly the same. Pebble was a watch that could make it through like 5 days with one charging. So this Pebble watch was running JavaScript. And, you know, they went out of business since, but there is another company that picked up and uses JavaScript to power their watches. So this is the Fitbit. Some Fitbit watches like the Ionic and the Versa, you can write applications and watch faces in JavaScript for. You will use SVG, you will use like JavaScript the APIs, and full ES5 support on a watch that can hold a charge for a week. It's not your Apple Watch that you have to charge every night. This thing will work for a week with having JavaScript executing on it. So again, you know, eventually the hardware is going to catch up. The engines are going to be smart enough that you can run JavaScript on constrained devices. And at that point, you would want people to be able to use the JavaScript skills on microcontrollers. And we're getting to the final stretch. So what about Arduinos? So I'm, you know, a bit sloppy on the terminology here, but basically what I mean by Arduinos is these devices. So we have been talking about JerryScript running on only 64 kilobytes of memory. Well, this device is an Arduino Micro. It has, oh shit, is it 32 kilobytes of memory in total? No, I'm sorry. No, that's the flash memory. That's how big your program can be. The whole memory of this device is 2 kilobytes, 2,500 bytes or something. That's the whole running memory of your microcontroller has. How do you run JavaScript on that one? Well, spoilers, you cannot really. I mean, JavaScript engine itself would take up the whole device. So this is where I introduce my, shameless plug to my personal project called Cloudboy. That is basically Cloudboy lets you. I mean, who have created games in JavaScript like HTML5, Pixie.js, whatever, Phaser. Okay, a few people. So this is good old-fashioned vanilla canvas in JavaScript. You can use vanilla canvas in JavaScript to create games. I mean, that sounds good enough, I guess. The thing that's interesting about this, Cloudboy lets you put those games onto microcontrollers, like the one you was showing before. But this is basically a microcontroller that you could build yourself. You can order all the parts and then hook it up. But you can also get nice, fancier devices like this one. This is basically the same exact device, except it runs. It's packed into this nice, well-built collection. I actually have here to show you that a game I just built for. I guess you'll know what is there. Oops. No, I probably should switch to video view. There you go. Okay. So let's try this again. Oops. Watch out. So, hello. I mean, I guess I'm on brand with the dinos. So, or some even niftier devices like this one. And the cool thing about this, not the two on the side, one in the middle. The cool thing about this one, let me show you. This is actually color. It is literally a tiny arcade machine, so it is very, on brand. So I'm gonna turn it on. You're gonna see it load. It's gonna look for an SD card. Basically, what you do, you put a bunch of files, firmwares in the SD card, and you can select from the firmwares. I have a very aptly named BrazilJS firmware. Let me see if I can get some. Okay, a bit better. So I'm gonna play this one. Oh, hello, BrazilJS. Oh yeah, it's like, Space Invaders, but in Brazil. And, I'm gonna die in a moment. Oh no. So here's the thing. If I just go to this link, I don't know how the Wi-Fi is holding up. If you get any data, try building in this URL into your laptop or phone. See what you can get out of it. Yeah, so if you click the link or you view the source, you'll actually see the same exact game, because this is a game in JavaScript running in a browser. I just hosted it on GitHub Pages. You don't need a server for it. It's just JavaScript and HTML. You're just using the canvas to draw pixels on a screen. So you can play the same exact game on your phone, share it with your friends, or hack around and put it into a tiny nifty device like this one, and play it in there. So how does it do that? Well, just a bit of spoiler. It actually translates your JavaScript code into C and compiles the C code. I know this is blasphemy, but it actually taught me a lot of things about JavaScript and engines and microcontrollers in general. So if you want to check this out, feel free to. And here's when this talk is only going to be shameless plugs from now. I have a workshop on the CloudBoy and JavaScript hardware stuff. So it's in Buenos Aires in October in NodeConf Argentina. I'm speaking and also giving a workshop on this. So if you're interested, it's like a quick hop, 1.5 hours. So feel free to check that out. But if you don't want to go as far as Buenos Aires, tomorrow in the lunch break, I'm going to be hanging out in the back, and then probably all the breaks, or, there are all the Trailblazers folks with their fancy robots. If you haven't checked that out, this is pretty neat. They are like champions of building robots. Okay, I just showed you how to use software to program your robots, but you still have to build the robots, right? So you have the consultants here for you. So I'm going to be hanging out around them tomorrow. So feel free to pop by. I'm happy to drop you a bunch of info about how this thing works, and I'm happy to demo you some of these stuff as well. Also, if you're into these stickers, I happen to have like a huge stash of Mozilla stickers and like foxes and like doges and other stuff. So if that's your thing, that might be a worthwhile endeavor as well. So thank you very much for listening. SL Softwork is my Twitter handle. There is a Twitter handle you can follow CloudBoy stuff on. So if you're interested in this JavaScript game stuff on microcontrollers, you can be sure to check that out. It's very alpha, so a lot of things are not working, but a lot of things are very interesting, have a very interesting future. So hopefully that will work. And you see the link on the top. You will see the slides. You can check out the slides on the link that I just linked. These are the links I just mentioned. So thank you very much. You survived. You're good. So only 2 more to go. Thank you.